In today's video, we'll be learning about logarithms. Now, what is a logarithm? This right here is a logarithm. Now, as you can see here, you would put log, the base, and the second number, which I'll get to in a bit. Now, what does the second number symbolize? Well, it's just what logs are saying, right? Is that what number, right, for the base? So what number can the base be raised to, so that when you raise it, when you evaluate, like in this case the base is 2, so like 2 raised to what number will give you 8. That's what it's saying. Now, the answer would be 3, right? So that means log base 2 of 8 would be 3, because 2 to the third power is 8. And you can actually rewrite this as this equation right here, if you want to check yourself. So 2 raised to the third power gives you 8. So that's basically what logarithms are. Now, the most common logarithm would look something like this. Now you might be thinking, there's no base, I've written no base, so how do you know what base this one is referring to? When there's no base listed, you are to assume that the base referred to is 10. So 10 to what power would give you 100? Well, answer is 2. And then you can validate that by doing this. Alright, the next one is ln. Okay, now what is ln? ln, right, refers to e. Okay, so for example, if you have this, e squared. Now, it's asking what number, right, for the irrational number e. Okay, and e is already kind of, you're supposed to assume that when you put ln, there's a base of e there, but it's just not listed if you ever see it without the e, without the base e. So it's just asking what number, right, can e be raised to, so that when you raise it, it'll equal e squared. Well, that's just simple, because it's just 2, right? E squared is equal to e squared, because when you raise e squared, then that will then equal here, e squared. Okay, now I'll give you some problems and try to do them by yourself. Alright, pause the video and try to attempt these problems. Alright, so for the first one, 3 raised to what number will give you 81? Well, 3 raised to the fourth power will give you 81, so the answer is 4. Second one, 2 to what power will give you 16? Well, again, this is 4. And for the third one, 4 to what power will give you 16? Well, that's just 2. And for the last one, e to what power will give you e to the fourth power? That's just 4. So this example was meant to show you that there's actually many different ways to get the same value, right? You got 4 3 times through different bases and the logarithms here, using different numbers of the logarithms here, right? And then e to the fourth power. So you can use different bases and what they're raised to, and all that, to get the same exact values, as you can see. Okay, so now we'll move on to the properties. Okay, so for properties, right, the first property states this: log, and we don't really care about the base right now, but it's fine. Yeah, it doesn't matter what the base is. This goes for any base, so we'll just go with base 10. And remember, for base 10, you don't have to write the base 10 out, because it's already implied. Okay, so log of a, right, we'll just do that, minus log of b, so some other number b, okay, is equal to, right, log of a divided by b, right? So basically what you're doing here is that you're just converting log a minus log b, and then writing a single log by first dividing a and b, and that'll give you a single log. The next one is log a plus log b is equal to yet another single log, which is log a times b. Okay? So now we're going to be doing some examples. So, first one. Okay, so let's just say you had log of 64 minus log of 32. How would you, so my question for you is that, how would you rewrite this? So take a moment and pause the video. Okay, so you'd rewrite this as log of 64 divided by 32. And that's just log of 2. Now since it's raised, it's 10, what is the base? Since the base is, in this case, 10, right? You can't really find any numbers when you raise it. When you raise 10 to, right? 10 raises to some power. You can't really find, in that case, like, what 10 raised to some power will give you 2. So in this case, you can just write it as log of 2. Since there's not really a definite or clear answer in that case. So yeah, you'd have to use your calculator in that case. But in this case, let's write one where you don't have to use your calculator. So log 3 raised to the 81, and then log 3 of 9. So then you can rewrite this as log 3 of 9, right? Because 81 divided by 9 is just 9. And this is just 2. So this gives you 2. And you can validate that by doing this, right? Log of 3 to the 81 is just 4. And 4 minus log of 3 to 9 is just 2. And that just gives you 2. 4 minus 2 is just 2. Okay. Okay, now for adding, if you have log of, let's just do log of 4 raised to the 16th plus log of 4 raised to the 4, okay, you can actually rewrite this as log of 4 and 4 times 16. And this would just give you log of 4 raised to the 64th power, and this is equal to 3. Now you can validate that, since log of 4 raised to the 16th, my bad, it's actually 2. So this actually can be written as 2 plus 1, right? Log of 4 raised to 4 is just 1, is then equal to 3. So we get the same answer. Yeah, so this is actually a very quick way to do it. These ways right here. Instead of doing the whole equation by itself, you can just condense it and then solve that equation or expression to make it simpler for yourself. Let's do one last example. Okay, so pause the video and try to solve this one by yourself. Okay, now you're done. You can rewrite this as log of 2 raised to the 8 times 16, and this is equal to log of 2 raised 16 times 8 is 128, and that gives you 7. So the answer is 7. And then again, you can validate this by doing 3 plus 4 is this equal to 7. So yeah, it all works out. That was logarithms and their properties, and I'll see you in the next video.